Okay, so what we're going to do now is we're going to put a toolpath on our card holder model. Okay, so to put a toolpath on here, what we're going to do is we're going to go from our design mode into our manufacture mode. Manufacture is where we've got toolpaths. I want to make sure my units are set to inches, and I need to create a setup. So click on setup, and the setup includes a stock definition and an origin. So I'm going to set my stock definition to my side offset of 20 thousandths, a top offset of 20 thousandths. We'll leave those be. For my setup here, I'm going to set a stock box point. I'll pick my stock box point. And I was having a little trouble picking there because one of those was the origin, which wasn't selectable, and the other one was the box point. And they were really close together, so sometimes you just zoom in a little bit and things will work out a little better for you. And the orientation, so my Z is pointing in the wrong direction. I'm going to select a Z plane. I'm going to pick this top plane here. And you see when I did that, it rotated this around. That really wasn't what I wanted, so I'm going to pick my box point again and pick my box point there. And that's just because when you change your plane, the Fusion tends to move the genome around. So when I had the genome on the side here, when I changed the plane, it moved it to kept it on the same side, kept it on the same top. So it's okay. Just make sure that when you finish here, that you have it looking like this. Your Y is pointing along the short direction, X pointing along the long direction, Z is pointing up from the top here. And if you hold down the Shift key and the wheel button, you can spin around a little bit and see that our Z is located on the top of the stock, which is perfect. Select OK, and there we are. And if you click anywhere in the drawing window, all that goes away. Okay, you can get it back by clicking on Setup. Okay, so now that we've got a setup, we're going to do some toolpaths on here. All right, first thing I want to do is clean out the inside there. So we'll do 2D adaptive clearing. I'll pick that face there. For the tool, I'm going to select from the aluminum library because it's got the right feed rates. I'm going to set the type to flat. And that gives me that restricts the choices quite a bit. 3/8 flat is what I'm looking for. Select OK. Tool number 1 is perfect. I'm going to set my spindle speed to 4,000. 4,000 there. My cutting feed rate to 20. Lead in feed rate to 20. Lead out to 20. Ramp to 20. Plunge to 10. Right. Go to geometry. Got that selected. Heights. Fusion is really good about that, sorting itself out. I don't need to worry about that. Passes, I do want to do multiple depths. I'm going to set my maximum roughness to 0.125. And on my stock to leave, my radial stock to leave, I want to leave 20 thousandths. Axial, I want to leave 0. I don't want to leave any stock axially. Okay, axially is vertical. And linking, we'll just leave our linking alone. Select OK. And there's our cutting. Nice adaptive clearing, nice entry, nice exit, all the rest of that. Very good. All right. Next up, I want to go ahead, since I've got the 3/8 tool loaded, I want to clean up the outside. Okay, so let's do a 2D contour. I'll pick the outside edge here. Okay, and it's remembering all my parameters from the last time I was in here doing a contour. That's good. So my geometry. My edge is here where I want it to be. Okay, so the arrow's on the outside of the part, right there, indicating that my tool is going to be on the outside of the part. That's perfect. Heights, again, Fusion is really good about sorting those out. It's got a graphic here showing me where everything is, but that all looks good. Passes, I don't need to make any multiple passes. I'm removing a very small amount of material. And linking, is pretty good, but my start point is not where I want it to be. I really want my start to be here. It's because I'm holding it in a vise, and I've got this is really my only clear approach. And when we put this on the simulator, you'll see what I'm talking about. So my entry position, I'm going to pick here. Okay. Doesn't matter exactly where. I just want it to enter like in the middle of that. So we'll select OK. There's my entry position. Now my lead in is actually pretty small. So let's go ahead and adjust this. These are my green arcs here. It's all pretty small. I want it to. I do have some material there. I want to do a little bit larger swing. So I'm going to edit this. For my linking, and for my lead in, my horizontal lead in, I'm going to set this to be 0.125, and for my lead in distance, 0.125. I've got my vertical there. My lead out to be the same as my lead in. Looks pretty good. Select OK. There we go. So my lead ins and my lead outs are a little bigger. That's good. Okay. So there's my adaptive clearing. There's my clearing around the outside. I want to clean up the inside here a little bit. So I'm going to do another 2D contour. This is going to be with a 1/4 inch tool. So I'm going to go to aluminum, type, flat, OK. Pick a 1/4 inch tool, then OK. Now if I do want to change the tool up, okay, if I want to change some of the parameters, like I've got some pretty bad parameters here, go ahead and hit select and change the tool here. You can't change the tool when it's in this part of the library. When it's in this part of the library, these are tools that are actually in the library. They're read-only. They have to be loaded into the document, like this is, before I can edit them. Right-click and edit the tool. And go through and mess with feeds and speeds and things like that. So I'm going to change my spindle speed here to 5,000. Cutting feed rate to 20. Lead into 20. Lead out to 20. Ramp to 20. And plunge to 10. And ramp spindle speed was also 5,000. Okay. Select OK. We'll override the feeds and speeds, and there they are, all set the way we want them to set. And it's 6 of one, half dozen the other. I can set them here, I can set them in the tool manager. Okay. Contours. Contours a little trickier. Okay, what I want to do here is I want to actually pick a partial contour, which means I need to pick an edge, and I need to pick another edge, another part of the edge, to get my contour selection. I say I want an open contour, and then I have to go and pick the individual pieces. Okay? And so I have to pick the individual segments, and this can get a little annoying. You want to make sure you've got all the edges picked. Okay? So make sure you picked all the way through there. We'll say accept that contour. Okay? And the direction is wrong. So I'm going to flip the direction. I'll flip the side. And that looks better. And I'm going to pick another contour. This edge and this edge. Say it's an open contour, and again I'm going to go through and pick the individual segments. And we'll say accept that and flip the side again. Okay, so we're looking at it from the right direction. For our heights, again, Fusion does a really good job of sorting out the heights. You don't need to mess with that too much. Passes. Sideways compensation is climb cutting. That's what I want to do. I don't really need to mess around anything here. I don't have any stock to leave turned on. That's great. Linking. I'm going to do a little bit larger lead in. Let's say 1/8 inch there and 1/8 inch there. Select OK. There's my lead-ins for my cleaning up on the outside. Okay, let's do an engrave. So I'm going to do a engraving here as a 2D contour. And I'm going to pick for the tool, again, aluminum. My type is going to be a ball mill. And I'm going to use my 1/8 inch ball. That's my tool number 3, which is great. I'm going to change my speeds here, 5,000 RPM, 5,000 RPM for this, maybe 18 for my cutting speed, 18 for this, 18 for lead out, 18 for ramp, 9 for plunge. Geometry, I'm going to pick the letters. Heights, I do need to mess with this. My selected contour, I want to go minus 0.01 for my selected contour. Passes are going to be fine there, and for linking, I want no lead in and I want no lead out. Okay. Oh, passes, sideways compensation, I want compensation type set to off. I'm engraving. And for engraving, I want it to follow the lines. I don't want it to offset to the left or right. Select OK. There's our engraving toolpath. Okay. I'm going to go ahead and save this. And I want to simulate this, but to simulate this, I need to do a couple of things. Otherwise they're going to bleed through the simulation. So I'm going to go back to the manufacture. I'm going to go back to the design tab, and I'm going to turn off that sketch so I can't see it. Come back to manufacture, and I'm going to change the display visual style to wireframe. Okay. Now when I right click and select simulate, turn off toolpath, turn on stock, and I have an opaque stock model. And it's really important to turn off the display of the part, because for things like the engrave, I'm really not going to be able to see the engrave because the part's going to show through. So we'll run this, and let's speed it up a little bit. There's our area clearance. Doing a pretty good job, clean up the outside, and we did something wrong there. We did not chamfer it. All right, here's my engrave. My engrave's looking pretty good. Maybe I'll back off the depth on that a little bit, but it didn't chamfer it. All right, so let's go back and turn on our display. Shaded with visible edges only. And let's put our chamfer operation in here. So we'll do a 2D chamfer. Put a tool. We're going to go back to aluminum. Select type as chamfer. And these chamfer mills are actually really bad. So I'm going to pick one, pick this 45 degree, select OK, and I'm going to go back here and hit select again. Now that it's in the document, I can right click on it and edit it and fix it. And it has all kind of stuff messed up about it. We're going to say it is a 0.25 inch by 45 chamfer tool. The diameter is 0.25. Tip diameter is 0.01. Flute length is 0.12. We'll leave the rest of those alone. that looks much closer to actual chamfer tool we'd be doing. While we're in here, do our spindle speed of 5,000, feed rate of 20, lead in of 20, lead out of 20, ramp of 20, plunge of 10, ramp spindle speed of 5,000. Select OK. Yes. I'll select OK. Got our parameters in here. For the geometry, I'm going to pick this edge and this edge. Chamfer width of 0.05, tip offset of 0.05, for chamfer clearance alone, and actually our heights. And for our height, I picked the outside edge of the chamfer, but I don't want that to be the bottom. I don't want that to be the bottom height. So I want the bottom height to actually be model top. Right? So the chamfer depth is going to be calculated from the contour. The contours in the chamfer extents, the chamfer shape, are going to be the shape that I picked. So this is actually going to have us at the apex, the theoretical apex. Okay. So select OK. And there's my chamfer toolpath. Okay. A little concerned about that, but it should be okay. It looks like it's 100 thousandths down. It should be right. And oh, last thing, I almost forgot. I did not face this. So let's do a facing toolpath with our 3/8 flat. Okay, my feed rates are all wrong for this. So let's go back to the 3/8 flat and edit that. That was going to be 4,000 and 4,000 for my ramping. Cutting rates of 20, 20, 20, 20, and 10. For the geometry, it's going to be the stock. For the depths, bottom height is going to be model top. That passes, cutting both ways. Select OK. There's my facing operation. And facing I actually want to have happen first. So we'll go to our, change our visual style to wireframe. Right click and simulate. And let's run that. There's our facing operation. Crank the speed up a little bit. Okay, so we're leaving, oh no, we're not leaving a lot of stock there. We should be good. There we go. So there's our engrave. I was going to bring the engrave up a little bit. There's our chamfer. There's all of our other cutting. Looks pretty good. So let's bring our engrave up a little bit. And that's going to be this one. Let's edit that. For our depth, set this to -0.005. Simulate this. Run. Crank the speed up a little bit. Now this looks like it's missing by a lot. This is the top edge of the chamfer. So it's actually doing perfect there. Okay. Last thing I want to check is I want to make sure that my chamfer is starting at the right point. It looked like my start point was on the arc there. This looks good, and our engrave looks great. So let's look at our chamfer operation. And our chamfer operation is in fact starting at a bad point. Look at that. Looks like it's starting right there. So let's edit our chamfer operation, linking, and for my entry position, An entry there. And for our lead-ins and lead-outs, our lead-ins and lead-outs are not doing what I want them to do. Let's do it. 125, lead-in radius, 0.125, lead-in distance. Okay, and I got a good start point there. My start point there is not good. And that's actually a problem. So let's do these differently. Here's my entry position. Okay, so I've got two entry positions. So there's my 2 points for my entry position. I have one here and one here. And my directions look good, so I'll select OK. There we go. I've got an entry going on here, an entry going on there. Perfect. Okay, back to my home position. Last time through simulation, we'll simulate, run, crank the speed up a little bit. Beautiful. Chamfer is happening like I wanted to. The engrave looks great. This is beautiful. All right. Set our display back to shaded with visible edges. And we'll save this. And now we want to post-process. So hit post here. And I'm going to select for the mill. There's a bunch of posts that are already in here. I'm going to select the IntelliTech. And for Fusion posts, a lot of the Fusion posts are for multiple machines, and you can customize the output a little bit by changing some of the options here. So we're going to set the machine type to bench mill. We're going to tell it to use a tool changer, allow helical moves. We'll leave our radiuses there. Don't want it to do either of those. That should be fine. Hit post. I'm going to save this to the desktop. And we'll say it's card holder. Fusion. And save that. And there is our toolpath. Our NC code.